Friends, in continuation of the inverter training videos from the basics, today we want to talk about multi-step or multi-stage frequency. In previous videos, we learned how to start the inverter from the keypad, from the network, and how to set the frequency using analog modes like voltage, current, potentiometer, keypad, and network. Today, we want to set the inverter frequency using multi-step or multi-stage frequency. For example, our speed 1 could be set to 30 Hz and speed 2 to 50 Hz. To do this, we need to use the digital inputs of the inverter. In previous sessions, through the frequency reference parameter, which was F0, we would tell the inverter where to take the frequency from. Where is its reference? For multi-step, we don't need to set the FRQ, and it doesn't matter what value our FRQ parameter is set to. When the multi-step digital inputs are activated, the frequency setting priority of this drive goes to the digital inputs. That means no matter what value FRQ is set to, if the digital input you have defined as multi-step is activated, the drive gives priority to the digital input and sets the frequency reference to the digital inputs or the same multi-step. So it doesn't matter what value you set FRQ to. In this example, our start and stop are also done via the keypad on the inverter. As we said, our DRV should be set to 0 in the main group or the operation group. But how should we set the parameters? We said that the digital inputs of the inverter P1 to P5 are assigned values in parameters I65 to I69. That is, I65 corresponds to digital input P1, 66 to P2, 67 to P3, 68 to P4, and 69 to digital input P5. But if we want one of our digital inputs to act as a multi-step, that is, to function as multi-step speed 1, we need to set the digital input we have in mind to value 7. For example, here I have selected P3, so I set I67 to 7, meaning my P3 is my first speed. I set I68 to 8 as my second speed, meaning digital input P4. Here I want to give two different speeds to the inverter, 30 Hz and 50 Hz. So where should I set the values for these frequencies? I need to set my first speed in parameter ST1, the second speed in parameter ST2, the third speed in parameter ST3, the fourth speed in parameter ST4, the fifth speed in parameter ST5, and so on up to ST7. But how does this actually work? Look, if your FRQ is set to any number, for this example, let's say it's set to 0, that means your frequency value is coming from the inverter's keypad. So for this example, I've set it to 0 on the inverter keypad. This is the same command you specify through that FRQ for the inverter. If you set it to 0, it means there is currently no frequency set on the inverter. Now, how does the multi-step function work? For example, you define P3, P4, and P5 as multi-step frequencies and set them to values 7, 8, and 9. Through the inverter, you can assign 8 different speeds to the inverter via digital inputs. According to the table provided in the manual, it says if your first digital input is activated, the value the inverter receives is the one specified in parameter ST1. If digital input P3 is off and digital input P4 is activated, the value you set in ST2 is sent to the inverter. Now, if both digital inputs P3 and P4 are activated together, the value you set in ST3 appears and is registered. If P3 and P4 are deactivated and only P5 is activated, the value in ST53 is used and so on, according to the table in the manual. The manual specifies which values to assign to the inverter. So ST1 becomes the first speed, ST2 the second speed, ST3 the third speed, and so on. ST53, ST54, ST55, and ST56. If none of these digital inputs are active, it defaults to the command you specified. Now, whether your FRQ is set via network, keypad, analog current input, voltage input, or any other method, it will take feedback from that and use it as the reference if none of the digital inputs are active. Now, as for the wiring, as we said, we've assigned digital inputs P3 and P4 to the inverter. If we have two switches, 0 and 1, to send different speed values to the inverter, we've assigned one of those switches to digital input P3 and wired it, and the other switch to digital input P4 and wired it as well. The common terminal is CM. We've connected the common of each switch to CM and the other terminal of each switch to the digital input terminals P3 and P4. So one digital input is P4. We connect one switch to P4 and CM, and the other digital input is P3. We connect the other switch 0 and 1 to P3 and CM. The condition for the multi-step function to remain active is that your digital input must always be in a constant on state. It doesn't work momentarily. So these are all the settings and wiring you need to do for the multi-step function. Let's go to the inverter and check the settings we've made together. For example, on this inverter, we want to set our first speed to 10, so we set parameter ST1 to 10, ST2 to 20, and ST3 to 30. That means once we activate digital input P3, ST1 will appear. Once we activate digital input P4, ST2 will appear. And if we activate both, the value set in ST3 will appear on the inverter keypad. Let's go to the test and try out this feature together.
Okay, as we said, in order to set the digital inputs to multi-step mode, we need to enter the in group. Now let's go to the digital input we want and set it to value 7. Here I've used digital inputs P3 and P4. P3 corresponds to in67, so I enter parameter in67. For my digital input P3 to function as my second speed, I need to set it to value 7. I enter it and set it to 7. Now I want P4 to be my second speed. So I set it to value 8. That is, I set in68 to 8. As we mentioned in the speed settings, after the speed command, if my speed command is 0, this multi-step setting becomes my first speed. If a frequency value is given for the command, then the value we set in ST1 becomes my second speed. Now I've set the command to 0, so my first speed is set in parameter ST1. You can see its value is 10, so my first speed is 10. Parameter ST2 is my second speed. I enter parameter ST2 and you can see its value is 20. I confirm it and go back. So my first speed, if my digital input P3 is activated, my frequency will be 10 Hz. And if my digital input P4, which is my second speed, is activated, my frequency will be 20 Hz. Now I'll start the inverter. I activate my digital input. If this was digital input P4 as well, I activate my digital input P3. For the first speed, you can see that my frequency becomes 10 Hz. Now I deactivate it. I activate my second digital input, which means P4, and you can see that my frequency value becomes 20 Hz. If you look at the value of set 3, you'll see it's 30 Hz. Set 3 means that both my first digital input and my second digital input are activated. So if both are activated, you can see that the frequency value becomes 30 Hz.